Hi everyone, good morning all. So today we are going to solve problems on verification of KCL and KVL for the given network. These kind of networks are called bridged T networks. You can see here a T network is there. On it a bridge of 1000 ohms is existing. So now we need to verify the KCL and KVL. Here when you understand the problem, the voltage at this node is 30 volts. The voltage at this node is also 30 volts. We need to find out the voltage at this point. I'm labeling this voltage as some Vx and this unknown voltage as some Vy. So if we find Vx and Vy, then automatically I can solve all the things. Okay. So now I am assuming this as a high potential. I am assuming the current flows from high potential to low potential, and I am marking this current as some I1 current, and I am marking this current as some I2 current, and this current as some I3. Okay, and coming to this node, I am marking this current as some I4 current, and this current as I5 current, and this current as I6 current. Okay, so like these six currents will be existing at two nodes. Okay, so we need to add these currents and to make it as 0. So in order to perform it, I'm going to apply nodal analysis is indirectly application of Kirchhoff's current law at the node Vx. At this node, I'm going to apply. Okay, so and similarly apply nodal analysis at node Vy. Okay, so when you are applying this, you can see here how the KVL we are going to get. Okay, so when you see these equations, to this node there's no entering current, therefore 0 is equal to the leaving currents are I1 plus I2 plus I3, and coming to this node the leaving currents are I4 plus I5 plus I6. You can see here there's no entering current, therefore entering currents are 0, that is equal to leaving currents. Now we have to express this current I is equal to V by R format. Okay, voltage by resistance. Okay, therefore 0 is equal to I1. How to write down the I1? Vx. So the leaving terminal is how much? Minus 30. So Vx minus 30 divided by R. R is how much? 2000 plus I2. How to write down this I2? I2 is equal to Vx minus 0 divided by 1000. Okay, so Vx minus 30 by 2000, Vx minus 0 by 1000. And what is the current I3? The current I3 is flowing in this direction, so we can write down this I3 as Vx minus Vy divided by 1000. Okay, now you are going to get one equation, and similarly like this you are going to get two equations. Then when you solve these two equations, then we are going to get Vx as well as Vy. So keep it aside. Now I'm going to take Vx as a common term. When you take Vx as a common term, then it is 1 by 2000 plus 1 by 1000 plus 1 by 1000 minus Vy by 1000 is the one equation. Okay, so this is 30 divided by 2000. When you use your calculator, this is 0.015 is equal to Vx of, use calculator, then you are going to get 0.0025 minus Vy of, so 1 by 1000 is 0.001. Okay, so this will act as equation number 1. Similarly apply here. Okay, so how the current I4 is flowing from Vy to Vx. So 0 is equal to, how to write down the current I4, which is Vy. So this is positive terminal, This is also positive terminal and this is also negative terminal. Vy minus Vx. So Vy minus Vx divided by 1000. So how to write down the current I5? This is nothing but the current I5 which is flowing. We can write down Vy minus 30 by 1000. So Vy minus 30 divided by 1000. Okay, plus how to write down the current I6? The current I6 is flowing like this. Therefore, we are going to get Vy minus 30 divided by 1000. Okay, so you segregate the terms of constant. So constants are, these are the two constants, these are in negative time. When you come to the left hand side, so 30 by 1000 plus 30 by 1000, so you have to take Vx as a common, that is equal to minus Vx divided by 1000, and here you are going to have the Vy term plus Vy 1 by 1000 plus 1 by 1000 plus 1 by 1000. So when you use your calculator, then you are going to get it as 0.06 0.001 Vx plus Vy of 0.003. So this will be equation number 2. So use your calculator and automatically from calculator we are going to get, using the calculator, solve these two equations. So Vx is equal to 16.15 volts and Vy is equal to 25.38 volts. So now let's try to verify whether it is correct or not and whether our equations are satisfied or not. So 0 is equal to Vx is how much? 16.15 minus 30 divided by 2000 plus 16.15 divided by 1000 plus 16.15 minus 25.38 divided by 1000. Okay, so this is one set of equation, and when you do it with your calculator and convert into milliamperes, this you are going to get it as minus 6.9 milliampere plus 16.15 milliampere minus 9.23 milliampere. Okay, so this is 9 and this is 7, so approximately 16, where 0 is equal to 0 ampere, which indicates that what is verified, our KCL is verified. Okay, so successfully we verified the KCL for the first loop. Okay, so this is our first loop and our KCL is verified. And second loop also, if we do it, substitute the values of Vx and Vy. So 0 is equal to Vy is 25.3 minus 16.15 divided by 1000 plus Vy is 25.38 minus 30 divided by 1000 plus Vy is 25.38 minus 30 divided by 1000. Okay, so when you do it, therefore you are going to get the values as 0 is equal to minus 4.62 milliampere, and here this one 25 is minus 4.2, and here you are going to get minus 4.62 milliamperes, and here when you solve this Vx minus Vy, here you are going to get it as, so this I3 and I4, so you can see here I3 is traveling in this direction and I4 is traveling in opposite direction. So I3 is minus, minus of minus is how much? Plus, which is 9.23. 4.23. Okay, so this is minus 4.6 minus 4.6 is equal to this value. So automatically 0 is equal to 0 ampere. That's how we are going to get. Now let us try to substitute this. So this is how our second equation also is satisfying Kirchhoff's current law. Now we have to satisfy our Kirchhoff's voltage law. Okay. Now let's try to mark all these currents in our branch. Okay. So I'm redrawing the circuit to understand. So this is 30 volt source and this is the 2000 ohm resistor. This is 1000 ohm and this is also 1000 and this is also 1000. This is 30. Okay. So here this is 2000 ohm. This is 1000 ohm. This is also 1000 ohm, 1000, and this is 30 volt source and this is the 30 volt source. Now we want to find the currents. Okay, so you can see this current which flows in this direction is, so the current which flows in this direction is minus 6.9 milliamperes, and we have to find the voltage here. Okay, so the current which flows in this direction is 16.15 milliampere. The current which flows in this direction is 9.23 milliampere. The current which flows in the same direction is also the same. So here the current which flows in this branch is minus 4 point. So you can see here the current which flows in this 1000 ohm is minus 4.62 milliampere, and we are having a bridge network, and through this also minus 4.62 milliamperes is flowing. So now these are all the currents we have been represented, and we need to find out all these voltages. Okay, so now let us try to redraw the network and write down its corresponding voltages. So when you see here, the voltage at this point is 30 volts. The voltage at this point is 30 volts. And when you multiply this drop, so is the voltage across 2000 ohm resistor is equal to I into R. So I is how much? Minus 6.9 milli into 2000 milliampere. Milli and 2000 will get cancelled, and you are going to get the voltage as a positive, negative, this 13.84 volts. Okay, so similarly when you find the voltage at this 1000 ohm resistor, so voltage at 1000 ohm resistor is equal to I is how much? 16.15 milli into 1000. This 1000 and will get cancelled, and here you are going to get an voltage of 16.1 volt. So the voltage at this point is 16.1 volt. This 0 volt, 0 volt, and 0 volt. And when you find the drop here, okay, so 1000, so the voltage at this point at 1000 ohm resistor is equal to minus 9.23 milli into 1000 milli will get cancelled, and minus 2.3 volts. So in this direction you are going to get minus 9.23 volts. So the polarities of current are marked like this. So the voltage at this 1000 ohm resistor is given as voltage at 1000 is equal to minus 4.62 milli into 1000 milli will get cancelled, and this is minus 4.62 volts. Okay, and when you do here, this is also minus 4.62 volts. Okay, so now let's try to apply the KVL. Okay, then you will get the clarity of how to apply. So see here, uh, current is leaving for the leaving polarity of the voltage. Let's try to apply Kirchhoff's voltage law. Okay, so current is leaving for the leaving polarity of the voltage is plus 30. Okay, so current is flowing like this. So here the leaving terminal is plus. So this is a plus 13.84 volts. Okay, so and here this leaving is minus 16.1 volt. So when you see here, the polarity of this one is, when you multiply here, you are going to get it as a minus 13 will called as minus. Okay, that is equal to 0. So this is 30 and this is minus 13 and minus 16, you are going to get as 0 volts. So here, so if you have confusion, you can check out here. So the polarity here you are going to get 2000. This is minus 13.8 volts. So this is nothing but minus 13.8 volts. Therefore, this is minus. Okay. So that's why you got the minus here. Now let's try to apply the KVL for the second loop. Okay. When you apply the KVL in this loop, apply Kirchhoff's voltage law. Okay, so when you go here, so what is the voltage at this point is 16. So 16.1 volt, and current is leaving. What is the leaving polarity of this voltage? Minus of minus 9.23 volts. Okay, and current is leaving this side. So when our current is leaving, what is the leaving polarity? Minus. So minus of minus 4.62 volts, and leaving terminal of this voltage is minus 30. So then you are going to get minus 30 volts. You are going to get it as minus 30. So this is 16.1 minus into minus is plus 9.23 minus into minus is plus 4.62, that is equal to 30. So 16 plus 9 plus 4 is 13, 13 plus this here equal to 30 volts is equal to 30 volts. The equation is balanced. So they feel the content is useful, please like the video and share with your friends. And if you have any doubts, let me know in the comment section. I'll answer your comments. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsi Ram. So thank you for watching. We'll meet in another video. Yours Ram.